This topic is about measures of central tendency and location. From Learning Module, Statistical Measures of Asset Returns. Median is the value where 50% of observations fall below it. Look at cumulative percentage column. Bin 6 ends exactly at 50%. The upper bound of bin 6 equals 46.88 billion euros. The lower bound of bin 7, starting at 50%, equals 46.88 billion euros. Median equals 46.88 billion euros, the boundary value where cumulative percentage hits 50%. With grouped data, when cumulative percentage reaches exactly 50% at a bin boundary, that boundary value is the median. No interpolation needed here, unlike when 50% falls within a bin. The 20th percentile equals the value below which 20% of observations fall. Look at cumulative percentages. Bin 1 ends at 8.33%. Bin 2 ends at 16.67%. Bin 3 ends at 25%. The lowest 20% spans all of bin 1, 0 to 8.33%, all of bin 2, 8.33% to 16.67%, part of bin 3, 16.67% to 20%. Since observations comprising the lowest 20% are distributed across bins 1, 2, and 3, the answer is A. Quintiles divide data into fifths, 20% segments. First quintile is lowest 20%, 0 to 20%. Second quintile is next 20%, 20% to 40%. Third quintile is next 20%, 40% to 60%. Look at cumulative percentages to find where 40% and 60% fall. 40% falls within bin 5, covers 33.33% to 41.67%. 60% falls within bin 8, covers 58.33% to 66.67%. All bins between these points contain observations in the third quintile, bins 5, 6, 7, and 8. Quartiles divide data into 4 equal 25% segments. First quartile is the lowest 25%, 0 to 25%. Second quartile is next 25%, 25% to 50%. Third quartile is 50% to 75%. Fourth quartile is the highest 25%, 75% to 100%. Find where 25% and 50% cumulative percentages fall in the table. 25% ends exactly at bin 3, the upper bound. 50% ends exactly at bin 6, upper bound. The second quartile, 25% to 50%, includes all observations above the 25th percentile, up to and including the 50th percentile. Bins 4, 5, and 6, covering cumulative 25% to 50%. Interquartile range equals Q3 minus Q1, the difference between 75th and 25th percentiles. Find Q1. Look for where cumulative percentage reaches 25%. Bin 3 ends at exactly 25%. Q1 upper bound is 33.65 billion euros. Find Q3. Look for where cumulative percentage reaches 75%. Bin 9 ends exactly at 75%. Q3 upper bound is 61.76 billion euros. Interquartile range equals 61.76 minus 33.65 equals 28.11. Quintiles divide data into 5 equal parts, 20% each. Second quintile is the observation between 20th and 40th percentiles. The upper boundary of the second quintile is the 40th percentile. To calculate 40th percentile, position equals n plus 1 times p divided by 100. It equals 4.4. It falls between fourth value 9.5% and fifth value 16.3%. Interpolate value equals lower value plus position minus lower rank times higher value minus lower value. It equals 12.2%. Topic: Measures of dispersion. Calculate the mean. Sum all 10 returns divided by 10 equals 12.36%. Find squared deviations. Sum squared deviations. Total equals 2315.98. Use n-1 for sample. Divide by n-1 equals 257.33. Take square root equals 16.04%. Identify returns below 3% target. 0.7% 2015. Deviation equals negative 2.3%. Negative 6.2% 2018. Deviation equals negative 9.2%. Negative 19.5% 2022. Deviation equals negative 22.5%. Square each deviation. Sum squared deviations equals 596.18. Divide by n-1 and take square root equals 8.14%. Semi-deviation is always lower than or equal to standard deviation, since it only counts losses. Coefficient of variation, or CV, equals standard deviation divided by mean return. Higher coefficient of variation means riskier. Mean absolute deviation, or MAD, is a measure of average dispersion using absolute deviations not squared from the mean. Topic: Measures of shape of a distribution. For a true normal distribution, 95% of observations fall within plus minus 2 standard deviations. This part is approximately correct. But in practice, real asset returns commonly show leptokurtosis, fat tails, more extreme outcomes than a normal distribution predicts. The statement is incorrect because normality of asset returns is empirically false, even though the 95% rule itself is valid for a true normal distribution. When an analyst assumes a normal distribution for fat-tailed asset returns, they will underestimate the likelihood of very bad or very good outcomes. Positive skew plus 0.8 means long right tail, occasional large gains, frequent small losses. Negative skew negative 0.8 means long left tail, occasional large losses, frequent small gains. Investors are loss averse, hate big losses more than they love big gains. They prefer distributions with upside potential and limited downside risk. Portfolio A, positive view, offers chance of large positive surprises with limited large losses. Portfolio B, negative skew, carries risk of large negative surprises, despite frequent small gains. Kurtosis measures combined weight of tails relative to rest of distribution. Normal distribution has kurtosis equal to 3. 5.2 is greater than 3. Distribution with kurtosis greater than 3 has fatter tails than normal distribution. Fatter tails mean more frequent extreme deviations. This is called Leptokurtic. Negative skewness means distribution has frequent small gains and a few extreme losses. Long left tail. In negatively skewed distributions, the extreme low values pull the mean toward the left tail. The mode stays at the peak, most frequent value. The median lies between mode and mean because it is less affected by extreme values. Order becomes mode is larger than median, median is larger than mean. High positive skewness means the return distribution has frequent small losses and occasional large gains. It's a long right tail. Large standard deviation means high overall variability or volatility in returns. This combination shows asymmetry toward extreme positive returns while returns spread widely. Most accurate description matches positive skewness definition with high dispersion. Kurtosis measures weight of tails relative to rest of distribution. Normal distribution kurtosis equals 3. Higher kurtosis means fatter tails and more frequent extreme returns. Equity returns generally show higher kurtosis than bond returns because equities experience more extreme price movements and larger outliers. Bond returns usually closer to normal with lower kurtosis and fewer extreme events. This matches option A description. Kurtosis of normal distribution equals 3. Excess kurtosis equals kurtosis minus 3. Negative excess kurtosis means kurtosis less than 3. Distribution with kurtosis less than 3 has thinner tails and flatter peak than normal distribution. Thinner tails mean fewer extreme outcomes. Flatter peak means less concentration around the mean. Topic: correlation between two variables. Correlation coefficient measures the strength and direction of linear association between two variables. It ranges from -1 to +1. -1 means perfect negative linear relationship. +1 means perfect positive linear relationship. 0 means no linear relationship. -0.85 is strongly negative close to -1. This means the two stocks tend to move in opposite directions most of the time, but not perfectly every time. Correlation sign depends on covariance sign. Covariance with real estate index returns -48.0. Covariance negative means returns tend to move in opposite directions. Negative covariance produces negative correlation coefficient. No need to calculate correlation because sign follows covariance sign directly. Correlation coefficient formula equals covariance divided by standard deviation of portfolio times standard deviation of bond index. Diversification benefits come from low or negative correlation between assets. Negative correlation reduces overall portfolio risk more than uncorrelated or positive correlation. Covariance between portfolio and real estate index is -48.0. Covariance negative means correlation negative. Negative correlation provides strong diversification benefits. Strength of linear relationship between two variables is measured by the absolute value of the correlation coefficient. Covariance alone does not measure strength, because it depends on the scale of the variables. The standard deviation. Correlation removes scale by dividing covariance by the product of the two standard deviations. Higher absolute correlation means stronger relationship, positive or negative. Bond correlation, absolute 0.6111. Real estate correlation, absolute 0.4848. Bond index has higher absolute correlation, so stronger relationship.